Every single cell in your body is screaming for it right now. And you don't even notice because you have never once in your life run out. Without it, your heart stops beating in rhythm. Your nerves stop firing signals. Your brain stops sending the electrical pulses that keep you conscious. It is the only rock human beings eat on purpose. It is the only mineral that walked out of the ground and into every kitchen on Earth. And for most of recorded human history, it was worth more than gold. Weighed against gold. Fought wars over, taxed into revolutions. But here is the mystery that most people never stop to ask. For millions of years, the ancestors of modern humans did not touch the stuff. No shakers, no mines, no trade routes stacked with white crystal. Just early hominins moving through the landscape, eating what the land gave them, with no salt pan in sight for most of that journey. Then, somewhere in the deep stretch of prehistory, everything changed. We went from opportunistic hunters who barely thought about salt to a species that cannot make food taste right without it. A species that built cities next to it, paid soldiers with it, and started revolutions over the tax on it. How did a plain white mineral rewire the human brain, build the first empires, and quietly turn us into the exact species sitting here today, reaching for the shaker before the first bite? Today we are going back further than most people think, past the pyramids, past the first farms, back to the moment our ancestors first tasted what history would eventually call white gold. Before we go back that far, quick pause. If you are the kind of person who wants to understand the biological why behind human behavior, not just the history textbook version, that is exactly what this channel is built for. We dig into the evolutionary stories that never made it into school curriculums. The hidden biology running underneath everyday habits, like reaching for salt before you've even tasted your food. If that sounds like your kind of rabbit hole, hit subscribe and turn on notifications, because we are going deeper into the human story every single week, and you do not want to miss where this goes next. All right, back to the beginning. To understand when humans started eating salt, you first have to throw out the assumption that salt only mattered once we started sprinkling it on food. Salt is not really about flavor at the biological level. It is about sodium, and sodium is one of the most non-negotiable requirements the human body has. Every nerve signal that fires inside you right now depends on sodium ions crossing a cell membrane. Every heartbeat, every muscle twitch, every thought you are having while listening to this sentence involves sodium doing its job somewhere in your nervous system. The body keeps blood sodium locked into an extremely narrow range, and if it drifts too far in either direction, the consequences are not mild. Too little sodium and you get confusion, seizures, and in severe cases, death. Too much and you get dehydration and neurological damage. This is not a system evolution built for fun. This is a system evolution built because getting enough sodium was, for a very long stretch of our history, a real and recurring problem. So how did early hunter-gatherers solve that problem before anyone had discovered a salt mine or a salt pan? The answer is blood and meat. Wild animal flesh contains meaningful sodium. Fresh blood is especially rich in it, carrying a sodium concentration close to that of seawater itself. For early humans whose diets leaned heavily on hunted meat, sodium was arriving pre-packaged, delivered inside every kill, no extraction required. This is a detail that gets skipped in almost every popular account of salt history, because it complicates the tidy story where humans discover salt at some dramatic single moment. The truth is messier and more interesting. Early humans were almost certainly getting adequate sodium for a long time without ever treating salt as a separate substance worth seeking out on its own. It was simply built into the food. But biology does not stay static, and neither did the human diet. As our ancestors migrated into new environments, followed shifting climates, and adjusted their foraging strategies, season by season, the balance of the diet moved. In periods and regions where plant foods made up a larger share of what was eaten, a problem started to emerge. Most plant foods, especially leafy greens, tubers, and fruit, are naturally low in sodium and comparatively high in potassium. But that is a very different mineral profile from meat and blood. A diet that leans more heavily toward plants, whether by necessity, by season, or by environment, quietly increases the risk of a sodium shortfall, even while it might be perfectly adequate in calories and other nutrients. This is where you start to see the emergence of what we can call the salt gap. Not a dramatic, sudden crisis, but a slow, biological pressure building underneath the surface of everyday survival. Bodies evolved for a diet with a certain sodium floor were now, at least some of the time, eating diets that dipped below it. And a body that runs short on something essential does not stay quiet about it. It generates craving. It generates a drive state that pushes the animal, any animal, toward behavior that closes the gap. This is not unique to humans. Every mammal that has been studied shows salt-seeking behavior when sodium runs low, from the deer that will travel miles out of its way to lick a mineral outcrop, to the elephant that will dig into a cave wall for salt-bearing clay. Early humans, watching this exact behavior play out in the animals around them constantly, because animal observation was central to survival, would have been positioned to notice something important. Certain places in the landscape pulled animals in with unusual consistency. And that noticing is where the next chapter of the story begins. It also helps to picture what those places actually looked like, because natural salt did not appear the same way everywhere on Earth. In arid regions, dried lake beds and inland salt flats left concentrated mineral deposits sitting right on the surface, no digging required. In other regions, underground water pushed through salt-bearing rock and surfaced as visibly briny springs, water that tasted noticeably different and drew far more wildlife than an ordinary stream. And along coastlines, sodium arrived through an entirely different channel altogether: sea spray, tidal pools, and the naturally salty flesh of marine animals, which meant that coastal populations of early humans were likely never short on sodium in the first place. This uneven geography of salt availability matters, because it means different human groups, scattered across different landscapes, were experiencing completely different relationships with sodium long before anyone had a word for salt at all. Some groups barely noticed a gap. Others felt it constantly. For the vast majority of the time our species has existed, sodium came bundled inside food, supplemented occasionally by whatever natural salt sources happened to be nearby. That equilibrium held for what was, on an evolutionary timescale, most of human existence. Then, roughly 10,000 years ago, everything about the human diet changed at once, and it changed because of agriculture. Farming reorganized human life around a small number of staple grain crops: wheat, barley, rice, millet, maize, depending on where in the world you were standing. These crops delivered something civilization desperately needed: calories that could be grown reliably, stored, and stockpiled at scale. But they delivered almost none of something the human body still desperately needed: sodium. Grain is remarkably low in salt content. A population that shifts its diet toward grain as the dominant calorie source is, without anyone intending it, shifting toward a diet that no longer meets its baseline sodium requirement through food alone. The body's need for sodium did not change one bit when agriculture arrived. What changed was the food supply's ability to meet that need. This is the moment the salt gap stopped being a minor seasonal pressure and became a permanent structural deficit written into the new agricultural way of life. So how did early farming communities figure out the fix? The most compelling explanations runs directly through animal behavior, the same behavior. Early hunter-gatherers had been watching for hundreds of thousands of years. Salt licks, natural outcroppings, and mineral deposits, where sodium concentrates at the surface of the earth, draw wildlife with remarkable consistency. Herbivores especially, because their plant-heavy diet leaves them chronically low on sodium, will travel real distances to reach these sites and lick the exposed mineral directly. Early farming populations, still deeply attentive to where animals gathered, because hunting had not disappeared just because farming had arrived, would have followed those same patterns to the same locations. And when they got there, they tasted what the animals were after. That first taste is worth sitting with for a moment, because it was not simply a moment of flavor discovery. It was a moment where two separate biological signals lined up at once. The taste system responded immediately and strongly, because the human tongue carries dedicated sodium receptors, tuned specifically to detect this one mineral, wired into a primary taste category alongside sweet, sour, bitter, and umami. That is not decoration. That is the nervous system, flagging something as important the instant it makes contact. At the same time, on some level, shaped by generations of accumulated experience, this mineral appeared to make people feel better, stronger, less foggy, especially for anyone who had been running on a sodium-poor, grain-heavy diet for a while. The eureka moment was not just, "This tastes good." It was the body recognizing, immediately and viscerally, that a real deficit had just been addressed. And there was a second discovery riding right alongside the first one, arguably even more consequential for the future of human civilization. Salt did not just make food taste better and make people feel stronger. It made food last longer. Meat rubbed with. Salt did not spoil the way untouched meat did. Fish packed in salt survived weeks. It never would have survived otherwise. Vegetables, preserved in brine, could carry a household through a winter that would otherwise mean hunger. Nobody needed to understand the underlying chemistry. The way salt draws water out of bacterial cells and halts microbial growth through osmotic pressure to notice the effect with their own eyes. Salted food simply lasted. And in a world without refrigeration, that single fact was about to reorganize the entire structure of human society. This is not just theory. The archaeological record backs up the idea that once agriculture created that sodium deficit, humans moved quickly from passively collecting salt to actively producing it. At Lunca, in what is now Romania, archaeologists have found evidence of organized salt production from brine springs dating back roughly 8,000 years to around 6,000 BCE. That date matters because production is a very different behavior from simply gathering what nature leaves lying around. Someone had figured out that brine, salt-saturated water, could be boiled down deliberately to extract solid salt at meaningful scale. Nobody invests that kind of fuel and labor into a process unless demand has already outgrown what passive collection can supply. And for populations who never had access to a natural mineral deposit at all, the drive toward sodium was strong enough to invent entirely new solutions from scratch. Traditional communities in tropical rainforest regions of Papua New Guinea the Amazon basin, and parts of Central Africa, places where natural salt sources are essentially absent, developed the practice of burning specific sodium-rich plants and using the resulting ash as a seasoning. Chemically, that ash performs almost exactly the same function as mineral salt. Different source, same biological purpose. It is a striking piece of evidence because it shows that the pull towards sodium was never dependent on having a convenient salt deposit nearby. When the environment refused to provide one, human ingenuity simply built a workaround. Once early societies understood that salt could preserve food, salt stopped being a mineral and became something closer to technology. Before refrigeration existed, before canning existed, before any modern preservation method existed, salt was, for enormous stretches of human history, the only reliable way to keep food edible through a season when nothing fresh was available. That single capability rewired the logic of survival. If you had salt, you had a way to store surplus. If you had stored surplus, you had a buffer against famine, a way to feed a population through winter, through drought, through a bad hunting season. Salt access, in a very direct sense, became power. This is exactly why early population centers cluster so consistently around reliable salt sources. Settlements like Jericho, among the oldest continuously inhabited sites in human history, sat near valuable natural salt resources, and that proximity was not incidental. A community that controlled a dependable salt supply could preserve more food, support more people, and weather bad seasons that would devastate a community without that access. Salt access shaped where people chose to settle permanently, and permanent settlement is one of the load-bearing pillars underneath everything we call civilization. Agriculture at scale, specialized labor, trade, eventually cities. And once salt became this valuable, the systems built around moving it and controlling it grew correspondingly sophisticated. Trade routes formed specifically to move salt from where it occurred naturally to where growing populations desperately needed it. Salt trade networks in ancient China date back thousands of years, tied to the earliest organized production efforts in the region. Trans-Saharan trade routes moved salt from deposits in the Sahara's interior south to sub-Saharan Africa, trading it, at points in history, literally weight for weight against gold, which tells you everything about how seriously ancient economies valued this mineral. Salt pans mattered enough to Maya political geography that controlling them shaped regional power struggles. Indigenous nations in North America went to war over control of salt springs long before European contact ever entered the picture. Rome gives us the most famous example, and for good reason. It is a genuinely striking one. Roman soldiers received a salarium, a salt allowance, and that word is still sitting inside your paycheck today as celery, a linguistic fossil from a time when salt itself functioned as a form of currency. The Via Salaria, the Salt Road, predates Rome's imperial period entirely, built specifically to move salt from coastal salt pans inland to populations who could not produce it themselves. The Roman state taxed salt, regulated its distribution, and treated its supply chain as a matter of genuine strategic importance. Not unlike how modern states treat energy infrastructure today. Because salt was a necessity rather than a luxury, its economics behaved differently from almost anything else traded in the ancient world. Demand for salt does not fall when the price rises the way demand for a luxury good would. People cannot simply decide to stop needing sodium, and they cannot simply decide to let their winter food supply rot because the tax on preservation went up. This made salt the perfect target for taxation from a ruler's perspective. Guaranteed revenue from a population that had no real alternative, and it made salt taxation one of the most consistently resented policies across a huge range of historical societies. The French gabelle, the salt tax of the Ancien Regime, was not just an unpopular fiscal policy, it was a tax on the ability to survive the winter, and the resentment it generated became one of the genuine grievances feeding into the French Revolution. Centuries later, and an ocean away, the British salt tax in colonial India became the exact policy Gandhi chose to target with his first major act of civil disobedience. The Salt March of 1930, 240 miles on foot to the sea, was chosen deliberately because salt was a necessity every single person in India understood in their bones. You cannot build that kind of unified public outrage around a luxury tax. You can absolutely build it around a tax on survival. Here is where the story bends back towards you. Sitting wherever you are right now, watching this. Every biological system we have just walked through, the dedicated sodium taste receptors, the craving triggered by depletion, the dopamine-linked reward response to salty food, all of it evolved across a period when sodium was genuinely scarce for a meaningful stretch of human existence, first from the plant-heavy diet shift, then intensified by the arrival of grain-based agriculture. That craving mechanism was adaptive. It kept our ancestors alive by pushing them toward a resource their bodies could not function without and could not reliably guarantee. The problem is that biology does not update itself the moment circumstances change. The craving system calibrated for a world of scarcity is still fully installed and fully active in a world of near total abundance. Salt is no longer rare. It is not hidden behind a difficult trek to a mineral lick or locked behind a punishing tax. It is sitting in a shaker within arm's reach at every meal, embedded in processed food at concentrations no hunter-gatherer diet ever approached. The ancient drive that once protected against a real and dangerous deficiency is now operating in an environment engineered, often deliberately by food manufacturers who understand exactly how powerful that dedicated taste receptor is, to trigger constant overconsumption. This mismatch has real, measurable consequences. Excess sodium intake is one of the significant contributors to hypertension, high blood pressure, which in turn sits near the top of the list of risk factors for cardiovascular disease worldwide. The same biological wiring that once meant the difference between a functioning nervous system and death, by deficiency now, in an environment of abundance, contributes to a very different set of health outcomes entirely. It is one of the clearest examples, anywhere in human biology, of an evolutionary mismatch. A system that made perfect adaptive sense for the environment it evolved in, and makes considerably less sense for the environment most humans actually live in today. So here is the actual answer to the question we opened with. Salt was never just a seasoning. It is one of the load-bearing pillars underneath the entire structure of human civilization. It closed a biological gap that agriculture opened. It preserved the food that let hunter-gatherers become farmers and let farmers become settled populations. It built the trade routes, funded the empires, sparked the tax revolts, and quietly wrote itself into the English language every time someone mentions their salary. Without it, none of the permanent settlements, none of the stored surpluses, none of the population densities that eventually became cities and states would have been possible on the scale they reached. Next time you catch yourself reaching for the salt shaker before you have even tasted the food in front of you, that is not a personal habit, and it is not a character flaw. That is a 100,000-year-old survival instinct. still fully wired into your nervous system, still running exactly the program it was built to run, in a world that has changed completely around it. You are not seasoning your dinner. You are performing a ritual old enough to have saved the species that became you. Stay curious. Stay evolving. I will see you in the next one.